Now that we've been building with tokens, we're going to add something new in our next project. The next project will be a token lottery system, where the user will be able to enter into a lottery with a smart contract acting as the ticket issuer. The hard thing about lottery systems and blockchain is that they require some amount of randomness to be fair. A distributed system coming to a decision on a fair random number is impossible, so we're bringing in a new concept to help us out. In blockchain, oracles can be used to retrieve random numbers for use cases on-chain. Oracles connect the distributed system to the data of the outside world, financial data, football game outcomes for betting markets, or even random numbers can be retrieved from these oracles. The way these oracles work is that they have a distributed set of data providers from the outside world pushing data on-chain. The on-chain data is then normalized within your smart contract, throwing out data oddities and taking a fair number based on the data provided. Random numbers are still difficult even with oracles, but they can be retrieved using a commit-reveal scheme. First, someone will commit a random number that is hashed with a random seed value. This commit value can be stored on-chain for use later. Once ready to reveal, the original committer will then push both the random number and the seed value, which can be verified against the original hash. We're going to do exactly this commit reveal scheme in our project. Let's get started. All right, so for this project, which we have called the token lottery, what we're going to do is we're going to have a lottery system that people can buy tickets from. They can use those tickets to then claim prizes, and then we're going to use something called off-chain randomness, so it's not actually on-chain, it's using something called oracles to decide the winner of the specific lottery. So let's get started. Before we do any code, what I'd like to do is I'm going to draw up all the different things that we need to build. So we're going to design our program. So this is the token lottery, right? The token lottery is going to have a few functionalities. So we have issue ticket. We are going to be able to, let's see, we're going to have to be able to do a commit reveal for randomness, and finally claim prize. And so thinking about this, what kind of instructions do we need? So let's start building out and designing our program. So the first instruction we obviously need, we're going to have to create the configuration for the lottery. So this is going to be like initialize config. So that will build everything that we need to for that lottery. The next thing that we might need is we might need a initialize lottery so that we can create all the different pieces for creating our collection, being able to issue tickets later, etc. Because we want to make sure that we initialize the lottery collection first before we can allow people to buy tickets. The next one, this one's going to be something that's going to be done by the user of this, but we're going to do a buy ticket function so that people can buy those tickets and then they can later use those to claim. So we're going to get into this a little bit later, but we're going to have two separate instructions. One's going to be a commit function, so commit randomness function, and the second one will be a reveal randomness, or choose, we'll call this choose winner. The reason being is whenever you do like a commit reveal type of scenario or scheme, you have to make sure that you do those in two different instructions, specifically also two different transactions. You cannot do the commit reveal both in the same transaction because there's some gaming that you can do there. And the final instruction that we'll need is claim prize. So claim prize. So you can see there we have six different instructions. You can already kind of think this is going to be a pretty thorough and in-depth smart contract that we're going to be building. Let's figure out what that config is. So we're going to call this the token lottery. This is going to be everything about the token lottery. We're going to need things like we're going to figure out who the winner is. This will be a ticket number, basically. We're going to have to figure out if the winner is already claimed, because what we don't want to happen is someone to be able to claim the prize immediately on token lottery without anybody doing anything. We want to make sure that it's bound by the time that the token lottery is taking. And time meaning we have a start time and an end time for the token lottery. Next thing we have is we're going to have an actual winning amount. So we have to have we'll call it a lottery pot amount. This is the amount of money that is up for grabs so that people can win it. Another one that we're going to have to need is we have to keep track of the total tickets. If we don't have the total tickets, let's actually call this total tickets. So total tickets. If we don't have the total tickets, we won't be able to figure out what number to choose from for our randomness data. So we have to keep track of that. We want to make sure that we have a price for all these tickets. So if there's a price to pay to get in the lottery, that's something we're going to have to keep track of. We're going to need two things that are not really obvious, but we'll need the authority. So there's going to have to be an authority that can do the commit randomness and choose winner. Otherwise, you can't really do much with it. And then finally, you'll need that randomness account. This randomness account is just to tie the account that is required to do the randomness information. We want to tie it directly to the token lottery config. All right, so we have a basic understanding of what our instructions are going to look like. We're going to have 6 different instructions. We have our config. Let's go ahead and start building. So we're going to open up VS Code, and I'm going to do new terminal. And as usual, we're going to do npx create Solana dapp, and I'm going to type it all out. So this is going to be a lottery. We're going to call it token lottery. Token lottery. We'll call it an XJS. For this project, we're not actually going to build a front end. It'll kind of be like a challenge for you to figure out how to build that front end. We're going to do a focus on the smart contract side. Tailwind, we're going to come with the basic stuff and it'll create. So I'll see you in a moment. All right, so we have a project. Let's go ahead and open it. So we go over here. I'm going to open token lottery. There we go. We have our project. It has an anchor folder. Looks like it has everything we need to get started. Let's close all these warnings. And I'm going to open a new terminal. And we're going to do first 2 things. npm install, just so that we make sure we have everything that's needed here. All right, now that's done. Now we're going to go into the anchor folder. Let me make this bigger for y'all. We're going to go into the anchor folder and we're going to do an anchor build, just so that we make sure that it sets up everything. So right there, we saw something that we want to keep track of. It says warning anchor version 0.30.0 is not equal to the CLI version. So as a note, throughout this entire bootcamp, we're going to be doing it with the 0.30.1 anchor version. So we want to make sure that we set up everything to be using that. All right, so what we're going to do is we're going to go update that. So if we go over here into programs.basic, cargo toml, you'll see down here it says anchor lang 0.30.0, update that to .1. We're also going to change a couple places. We're going to change this to say, we're going to say token lottery. We just want to make sure that that's everything. This one's going to be an underscore. There we go. Actually, let's just make everything underscore just so that it's easy for us to understand and remember. So I'm going to update this. I'm going to update this. We're going to update this folder path name also just to be token lottery, the lottery. Okay, token lottery. So let's update all the names. Let's make sure that it's set here. So there's going to be a programs here. There we go. Update that to token lottery. And then finally, we got to go into our librs and update this to say token lottery. Okay, so now we can do an anchor build. So everything completed, everything ran perfectly, so we can actually continue. So we have our greet. It has a message of GM, so good morning. We're going to go ahead and remove that, and we're going to go back over to our specific design diagram that we created. So here we have initialize config. So we're going to build that one first. So we'll call this instruction initialize config. We already have the context of initialize, and it's going to do a bunch of different things. Right here, we know that we're going to create an account because we have to create that specific config account we're going to call it the token lottery account with all that data that we had over here. All right, so because we know that we're going to have a payer. It's going to be a signer. I'm going to use lifetimes here. If you don't know what lifetimes are already, I would recommend looking them up in the Rust book. They're not that hard. All right, so this is going to be account mutable because we are going to use a pair and there's going to be LAMP ports deducted from the account. And then we're going to have another account. So this is going to be account, and I'm going to enter here. We're going to initialize it. The pair for this will be pair. I'm just going to put 8 here. We're going to update that in just a minute once we create the account. Then we're going to have 2 different things because it's going to be PDA. I'm not going to do it as config. I'm going to do it as the token lottery. And because it is a PDA, we're going to need a bump. And so this is going to be a pub token lottery, and it's going to be a specific account. We're going to call this info token lottery. And because we're creating it, you can see Copilot already knows, because we're creating an account, it's going to say like, hey, we need the system program. Let's go add that system program. All right, so we have this token lottery. We have to actually define it now. So let's go define it real quick. We need an account. It's a pub struct token lottery. You can see here, it's asking us to do a bump, and we're actually going to keep that. It wasn't in our original design, but best practice, if you're using a PDA, you want to save the bump in the actual PDA. This allows you to use less compute later on. Just make sure that you always save the bump in the PDA and then use that to derive it later. All right, so let's set all this stuff in the token lottery. Before I do anything, I'm going to do the, what is it called? Derive, the macro for derive init space. And then because I did that, I can now go the 8 bytes for the anchor discriminator plus the token lottery init space. This will make sure that it auto-generates the amount of bytes that it takes to store this token lottery on chain, and I don't have to do some math. I always am for that. All right, so let's go ahead and set everything. So first off, we need a winner. We're going to have U64 as the ticket numbers. Next thing, let's see, we need the winner claimed. So this is going to be winner claimed. This is going to be a bool. Next one's going to be start time. We're going to do this in slots, which is a U64. We need the end time. We need a lottery pot amount. So pub lottery pot amount. This is going to be U64. The next one we have is the total tickets. So pub total tickets. It's going to be a U64 as well. We have the ticket price, and then we have an authority. So this is going to be pub authority. This is going to be it's going to be a pub key. Let's remove that extra space right here. And then finally, we have the randomness account, which is going to be another pub key. So randomness account, not randomness account. There we go. All right, so we have this big struct. We should have everything we need to get started. Let us start filling this in. I'm going to do a quick anchor build just to make sure that we wrote the right code and we don't have any typos anywhere. All right, everything compiled. It's great to hear. All right, so what we're going to do is we're going to start filling out this configuration. So in order to do that, we just start writing all of them. So I'm going to remove this underscore here because we're actually using the variable. So accounts dot, we're going to do the token lottery equals, we want to make the bump because remember, we always need to remember to set the bump. We're going to do context.bumps.token lottery. This is basically just going to set it in the account for the bump that was used to derive this token lottery. Next up, we have the start, end date, and price. So start, end time, and price, right? Those are actual parameters that we need to pass in. So let's go ahead and pass those in. So we have start of a U64,
end U64 and price also as a U64. So we have this. We're going to have context.accounts.start time is start, end time is end, set the ticket price. We want to set the authority. So the authority will be the payer. Then we need the lottery pot account amount to be 0. It actually sets it as 0 by default, but we're going to set it just to be verbose. We want the randomness account to not be set yet. We're going to do that whenever we commit the randomness. So dot randomness account equals pub key default. So it's going to be a default pub key. Can't derive that. That's fine. And then finally, we're going to do context.accounts.token lottery winner equals, well, not the winner. We want the winner claimed equal to false. Let's do the winner. Let's change this to winner chosen just to be a little bit more understanding what we're doing, because it's false. We haven't chosen it yet. We're waiting to choose it before we continue. All right, so we set everything. Let's go ahead and test it. All right, compiled. Let's go over to the anchor tests. We're going to update this to say token lottery instead of basic. So token lottery.spec.ts, and I'm going to call this the token lottery, and should init config. So then a couple of things here. What we see is this is trying to import basic. We need to import, instead of basic, we're going to have to import the token lottery. So this is going to open token lottery instead, and that's going to be token lottery. This is so that we can use the program, and then I'm just going to copy and paste this right here. This is so that we're using the program from Token Lottery. Now note, this might be different than other tests that we've done throughout this bootcamp. We're going to use the standard anchor test instead of bank run for this one, because we're going to do a lot of funky things with accounts and programs. A fun challenge would be to figure out how to do this with a bank run on your own. But ultimately, it's only a few lines of code difference to get set up. All right. So I'm going to remove these. One other thing that I'm going to do is I'm going to create a provider equals anchor.anchorprovider.env. And then I'm going to set the provider here. This is so that I can grab the wallet, which I'm now going to set as the wallet down here. So we'll set also a wallet, const wallet equals, this is going to be provider .wallet as anchor wallet. All right, so we have the wallet, we have the provider, we have the program. Now we can actually do things with the program. So let's go ahead and do it right here. So I'm going to do const. We're always going to do the instructions first, because it's simpler to understand what's going on. So this is the init configuration instruction equals await program dot methods dot initialize config. Now you can see here has an error. Let's go figure out why it's missing. So it's because we don't have that start time, we don't have that end time, and we don't have the what's the last one that we needed? So start, end, and price. So let's go ahead and set those. So it's going to be U64, or sorry, new anchor BN, because that's how you set the price, or the U64. We're going to do a few things. I'm going to make the start of 0. We're going to go grab a Unix time from online. That's going to be really high, just so we can test this. So just grab that real quick. Boom, that's really high. Let's make it even higher, so it's way in the future. And the price, let's make the price 10,000. This is 10,000 LAN ports. All right, so we have the instruction. Now we have to actually create the transaction. So const tx equals new anchor.web3 transaction .add initialize config instruction. Let's see what happened with it. Let's see, argument type of pair writable. Okay, so we're just missing something. That's fine. We can do that. So this is just because it's missing some of the information needed to complete. So let's go add all of that. All right, so the things that we need for this transaction is we're going to need some things from the block hash. So we'll do a block hash with context equals await provider dot connection dot. We're going to use get latest block hash. There we go. And now we just need to set everything right here. So the fee pair, we're going to set the fee pair as my wallet. We're going to set, let's see, we're going to set the block hash as the block hash with context. And then finally, we're going to need it's the last valid block height, which is going to be block hash with context dot last valid block height. There we go. And let's see, all the errors didn't disappear. All right, so we're just still missing something. This is because, let's see, this is missing an add. Let's see. I think it's because we don't have the right information to run this. So let's go back up here. So it's program methods initialize config perfect dot. Oh, it's not an instruction. This is a builder. So we have to actually set as dot instruction. There we go. Everything's happy. Yep. We got the transaction. This is our transaction signature. And now we just have to send it. So what we're going to do is we're going to do const signature equals await provider dot web connection. We'll do it with anchor. So anchor dot web 3 dot send and confirm transaction. This will need a connection. So we're going to do the provider dot connection. We need the actual transaction, and we have to need the actual payer as well. So wallet dot payer. There we go. I'm going to add a semicolon just for making it look nice. And then we just do a console dot log your transaction signature. I'm going to go ahead and pull this one out because we don't need that until afterwards. Let's run it. So anchor test. One thing I'm going to do is I'm going to run a separate local test validator. So we have, let's actually remove that. Kill terminal. I want a specific type of terminal. I want my ZSH, not just a plain bash terminal. So separately, we're going to set up a local test validator. So if I run local Solana test validator, it'll run my test validator. And then here, I'm going to do anchor test -- skip local -validator. This is just so I don't have to wait for the startup every single time. Also, we're going to do some special things with the local validator. This will make it nicer. So let's run it. All right, so it failed. Let's go see why it failed. Should not in config. Program error 1004. So that's a custom program error. This is usually, I'm probably just missing something. We're going to do a trick here. We're going to add a skip preflight checks so we can actually read the full error. So we're going to skip it. Going to run that thing again, and then we're going to go check that errors. All right, so let's grab that transaction signature. There we go. We're going to go over here. We're going to go to our Explorer. Make sure that you set it to local. Go look at that transaction signature. You can see here, declared program ID mismatch. Perfect. So that's a better error. Let's go figure out what that means. This is because if you go over into librs, you can see that it says HVX. However, when we deployed, it now is ESFW. So let's go update that. And I believe you have to do it in one other place. Let's go find it. I believe it's in the cargo, or it's in the anchor toml right here. So that also needs to be ESFW. All right, let's run it. Let's do an anchor build with it real quick. And then we'll do an anchor test. And that way it will start up with all of the right program IDs. Anchor test. And deploy again. We'll deploy to that same program ID. and then pass. So we can see here, if we can go grab that signature real quick, and I'm going to go paste it in here. There you go, success. And when we go all the way down, we can see initialize config, return success, and then it took some compute units. Fantastic. It would initialize our config, it created our account. Now we can move on to the next step. All right, so we've initialized the config. The second thing that we had here, if we remember from our design, is we have the initialized lottery. So there's a number of things, different things that this initialized lottery is going to do. I'm going to move this initialized config over here, and just so we can draw up all the different things that this lottery is going to do, because it's going to do a lot. And it's going to be quite a lot of work as well. All right. So this initialize lottery, right? So we're going to do initialize lottery. It's going to do quite a few things. The first thing it's going to do is it's going to create a collection that is owned by the program. This is because we want the program to have full control of minting more tickets. We don't want to have anybody else have that control other than the program itself. It's a separation of concerns, security thing, that's fine. So create a collection that's owned by the program. This is a lot of work, and this will create mint. So create collection, create something called a master edition, so that you can mint more tokens. Or sorry, this is not a master edition, it's a metadata account. So metadata account. And then we're going to also create verify the collection. All right. And if you go over here, so if we go over to the token metadata docs, we can see here that it's very important to check that this verified thing. Let's see if I can make this a little bit bigger. All right, so this is kind of what we're creating here. We're going to create a verified NFT, which includes the mint account and the metadata account. We're going to have that collection NFT, which is also is a separate NFT that will have a collection, some details, and have a mint account. And then we're going to verify it, which sets this collection metadata in the metadata account to the key equal to the metadata, as well as verified equal true. So this is what we're basically going to build, is these 4 accounts right here. Let's go ahead and start building them. All right, so first thing we're going to do is we're going to create a new instruction. So pub function initialize lottery. This is going to have a new context. We're going to do context initialize lottery. This is going to return a result. I'm going to remove all this extra code. And now we have to actually build out the initialized lottery context. All right, so let's go ahead and throw it all the way right after initialize. We're going to set it right here. I'm going to make my term a little bit smaller. So this is going to be a derive accounts. So, and then pub struct initialize lottery. And it's going to have a bunch of different things. So one thing it's going to need is it's going to need it's going to need a signer. So let's do account mutable pub pair signer. And then we know that we're going to be creating accounts. So let's already create that as well. So system, program system. All right. So we have this initialized lottery. I'm going to go ahead and do this real quick. We've started writing the code for the lottery thing. So let us compile it and make sure that we didn't make any mistakes in the meantime. Okay, so everything worked just fine. Because we're going to be using token accounts, we want to make sure that we add the specific cargo crate for the specific crate for Anchor SPL. So Anchor SPL. This is actually, it's a cargo add, what is it called? Anchor. Let's go grab the docs real quick. It's always good to have the Anchor Lang docs available. So this would be SPL. What is it? Anchor SPL. All right, so let's go grab this Anchor SPL thing. So there we go, Anchor SPL. So we need to add this right here. There we go, it's adding. Okay, looks like Rust analyzers are still catching up. Another thing is we're going to have to make sure that we add something right here of anchor-lang/ or anchor SPL/IDL build. It's just so that we make sure that we have the right IDL stuff for it. Right here we have anchor SPL. We want to make sure that we have the features of metadata. So I'm going to add it right here. So this is version equals 0.30.1 / features equals metadata, I believe is what it's called. There we go. And I'm going to do an anchor build one more time just to make sure everything is set up correctly. All right. So it's because, let's see, I missed something here. Oh, I missed quotes. That's fine. I'm okay with that. All right. So it compiled. That means we added everything correctly. I always like to do that just to make sure that everything is right. Let's continue with creating this initialized lottery. So we have the token, we have the system program, the pair. I just spoke about what I wanted to add as well. We want to make sure that we add the token program that we're going to use. So pub token program. This is going to be an interface program, because we want to make sure that we allow any type of token program to exist. So interface of info, I believe it's what? Token interface? Yeah, token interface. There we go. All right, so we have the right token program. We're also going to need the associated token program. So pub associated token program. This is going to be of type program info, not token interface, but associated token. There we go. We're also going to need what's called the token metadata program, because we're going to be creating those metadata. So token metadata program info token metadata. It's going to say that we need to add it. So let's go add it real quick. We need to make sure that we add it here and save. Running into an error. We'll fix it in just a moment, and that's okay. Is not satisfied with ID is not satisfied. All right, we'll fix that in just a moment. I'm just going to make this a little bit prettier, because otherwise it's going to be a mess in the long run. I think this is the wrong token metadata is the issue. All right, so let's add all that. This metadata that we need is actually from a different crate. Let's see if it knows it. Otherwise, I'm going to have to add it individually. Oh, so it's not actually token metadata, it's metadata. And this is under Anchor SPL metadata. Perfect. All right, so everything is happy there. Next up, we need to actually start creating all of our different accounts. So these are our collection mint, our metadata account, our actual collection token account, so that we can have it on chain, and then finally our master edition account. So let's start off with some of them. So first off, we're going to do the collection. We're going to have to do the collection mint. So this is going to be an account. This is going to be in it because we're going to initialize something, pair equals pair, so that we have something paying for this thing. Since this is a mint, we're going to have mint decimals of 0 because it is going to be a collection mint. This is going to be mint authority. I'm going to set it to pair, but we're going to change it in just a moment. We're going to also change this one to be something else in a moment as well. We also need the seeds. We're going to make it a PDA just so that we can easily derive it later. We're going to call this collection underscore mint as ref. And because you have seeds, you must have a bump. Now, unfortunately, because this PDA is a mint account, we can't actually store the bump inside the mint because it doesn't have a space for it. That's okay. We'll be fine with that. This is going to be of type interface account because it is could be a different type of token account. Info mint. There we go. And this mint, let's see, this mint should be the interface mint. All right, save. So that is our collection mint. The next two are, let's do the collection token account first. So the collection token account is an account. It's going to be, we're going to initialize it. We're going to have a pair. That's perfect. Oh, it did a whole bunch of things. I don't want all of this here, so I'm going to remove all of it, and we'll keep going through it in just a moment. All right, so we have the token mint equals the collection mint, and then token authority. We're going to have the authority to be itself. So we'll leave it for pair, we'll update it. So pub collection token account is of type interface account because it can be either type of account, / info token account. And it's going to be token interface. Perfect. So we're going to update a few things here. I don't want the pair to be the authority of the collection. We want the PDA to be authority. Same with the collection token account. We don't want the pair to be authority, so we're going to make the collection token account the authority of itself. All right, so we have those. That looks fine. Just to make sure that we're doing all right, I'm going to do an anchor build. Everything compiled fine, we can keep going. All right, so the next two things, we're going to do something that's not normally best practice, but it's okay in our case. You'll learn in the security module if you've if you went through it already, why it's not best practice, but it's okay. So we're going to use two different accounts. The first one is going to be the metadata account. So metadata, and this is we're going to call it metadata, an unchecked account. And the reason being is it's going to be checked and created by the actual metadata program. The other one is we're going to need the master edition. Also same thing. It's going to be checked by the metadata program. Because you do these two things, what's going to happen is when I run this, it's going to say error, warning, you have an unchecked account. It's always good of an error to get because you need to know what you're doing when you're using these. You can go check the code for the token metadata program right here. You can read it. You can see that it's actually going to be checking these accounts. And since we're CPIing, we should be okay. So let's do an anchor build and see that error. All right, as expected, safety checks failed. Didn't work. We didn't want it to work. Great. So we're gonna have to add some checks to say like, these are checked by the token meta program. So this account is checked by the metadata smart contract. And I'm going to copy this and put it in two places. All right, so we have these. Now, there's one more thing I want to do is that these accounts can actually be derived. They don't have to be just mutable. We're going to actually set all the seeds and stuff here so that we don't have to derive them ourselves. If we derive them ourselves, it's more work on us. Let's just make it auto-derived every single time. All right, so for this one, we have to add those seeds. We're going to add empty seeds real quick. Needs a bump. And then finally, it will need to specify the program that it is getting or deriving these from. So this would be seeds program equals the token metadata program. All right, and the seeds for this one are as follows. First, it's metadata. Then it's going to be the metadata program, so token metadata program. Next up is the mint. So we're going to have to do the collection mint as ref. And let's see, it's got an error. Let's figure out what it is. It's just missing a comma somewhere. Oh, it's missing the comma right above it. That's fine. All right. All right, so this needs to be the key. Yep, key. That's fine. Save it, and there we go. So we have these as the seeds here, and we're going to copy and paste this real quick. So I'm going to copy and paste this account real quick because it's very similar. And instead of, let me just do some enters here so it's easier to read. So token, metadata program, collection, mint. And the final one for this one is we have the token metadata, program, collection, and the last one is not actually empty, but it's going to be addition. And I need a comma up ahead. And let's see what, oh, I had a dot. That's fine. So if you're ever interested in how to derive this, you can actually derive it just based off of the smart contract itself. So we can go to the code, we can see here, here's the seeds for metadata. It's that prefix that we have, the program ID and mint info, everything's there. You can also do the code diving for this one as well. This is for the master edition. You can just go to the MPL token metadata program. It's on GitHub. You can go look through it all. But we have everything here. We have our checks. So check. Let's make sure we have those. Otherwise, we're going to get another error. Let's go ahead and anchor build it. All right. So it's saying that token metadata is not there. Let's see. It's right here. So token metadata program. I probably just set it incorrectly, and that is fine. Token metadata program, token metadata program, token metadata program. Let's see. What is not in scope? Let's find it. So one thing I noticed is it should be .key, because otherwise it won't know to use the key. It'll just use some, I guess, some bytes or something. Let's go ahead and build it and see if that fixed it. Yeah, that fixed it. Just needed to be .key. Yeah, so it's just because it could not find it because it needed to be a key instead. All right, so we have everything. It builds. Now we can actually start writing the code for initialized lottery. So there's going to be a whole ton of code in this specific function. We're going to go through it line by line. All right, so the first thing is we're going to do a bunch of things with CPI, and they're going to be signer seeds. They're going to need signer seeds. So we're going to do let signer seeds. We're going to do equals. It's going to be a type of reference U8. This is how all signer seeds look like. We're going to go backwards there. There we go. Equals reference. Whoops. Reference. We're going to have to add our collection mint. This is because we're going to use the collection mint to do a bunch of things as ref. And then finally, reference. Let's change this from underscore context to regular context. Context.bumps.collection mint. So now we will be able to sign with the PDA that is the collection mint account to do a bunch of things, which we'll need in just a moment. So first thing, we need to be able, I'm going to create a message that's going to be creating mint account, because that's the first step that we're going to do as referenced when we were doing the Excel draw. We have to create the mint, create the collection, create the metadata account, and verify the collection. All right, so let's go ahead and create that mint. This is going to be something that you've probably done before. Mint2, this needs a CPI context. We're going to do it new with signer. New with signer. There we go. I'm going to go ahead and put a question mark there because we need it. We'll need it in just a moment. A new assigner, we have to provide the program. So it's going to be the token program, context.accounts.token program.to account info. The next thing we'll need is we're going to use mint2. This is just kind of to help us out. with creating the accounts. There we go. You can see here it already kind of tells us all the different things we need. Some of these things don't actually exist, but we need to make sure the mint is the collection mint. It's going to mint to that collection token account, and the authority is not there, but it's going to be the collection mint as well. As we remember, it's the collection mint. All right. We're going to make sure that we set it with the signer seeds. And we need to mint 1. So we're minting 1 to our token. See, this is saying that I can't find it. Let's go ahead and add it real quick. Import mint 2. Yeah, sure. Let's do it. Import from token. Yes. All right, it's saved. Let's do an anchor build and make sure we did everything right. So one thing I realized is that this mint 2, it's coming from, let's see, it's coming from Anchor SPL. We actually need to make sure that we're using a different mint 2. So we need to import the, let's go backwards a little bit. We actually need to import a different mint 2. And this one's going to be a token metadata one. So it's going to be Anchor SPL. It's going to be, let's see, not token metadata, but token interface. Interface. And this is going to be mint_2. Might have to write it myself, and that's okay. All right, so we need to add it here. Token interface, it's right here. We need to add the mint_2 and mint2. There we go. We need to make sure that this is using the right thing. Remove that. All right, so everything should work. Let's just do an anchor build, just make sure that we did it correct. All right, so we have the mint2. It's minting a single token to our token account. Next thing we're going to do is we're going to create the metadata account for that token. So let's create those metadata accounts. So message, just to make sure that we have all the message stuff for it. Creating a metadata account. We'll remove these later. That's fine. So this is going to be create metadata accounts v3. You can see it's already kind of knows what I want to do. I'll leave this here. We're going to fill this out. It's a lot of things we need to fill out here. All right. So first is that context. This is going to use a new context. So we need a CPI context. First one, this one's going to be new with signer because we have to sign with that. Keep that collection mint account again. You can see it already says your program, what accounts are you doing, and your signer seeds. Thankfully, those signer seeds are the same ones as earlier, so we don't have to worry about that one. The program is going to be that context.accounts.token metadata program, .to account info. Perfect. We're going to use a fancy helper for us. We're going to do create metadata accounts v3. This is just to help us out. And you can see there's a lot of different things here. All right, so let's start filling this in. It's got a bunch of red lines. Let's make sure to fill it in. All right, so the metadata is going to be that metadata account. That works. The mint is that collection mint. The mint authority is itself. Perfect. Payer, the one who's going to actually pay for this is the payer. Great. There's the update authority. We want to make sure that's not the payer. We want to make that the collection mint. So let's go ahead and paste that over here. System program is system program. You can see it requires rent. We didn't actually include rent. So let's go ahead and go add that real quick. So going back down to our context right here, we're going to have to go add a rent account. So pub rent sysvar info rent, and we'll just update this up here to be, instead of the system program that was auto-generated, rent. All right, and then this should be everything. Let's see what it's missing. Expected accounts v3 lifetime. What is this? Expected found mismatched expected pub key got account info. So it's missing something. Let's figure that out. So I figured it out. This up here, just the auto import did not work as expected. It's grabbing it from the wrong import here. So you can see it's doing import of Anchor MPL token metadata That's completely different than what I actually wanted. It's actually, there is a create metadata account v3 right here. It should be anyways. So I figured out here, this import is using the wrong create metadata accounts. It's using it from MPL token metadata. So that's an easy fix. We should be able to just update this here. It's also because I did it, it's under account. It needs to be accounts v3. So we'll just remove this right here, save it. It's not being used, you can see, and I can go back down here, update this to say accounts, and then it should be happy. All right, cool. All right, so this is a reference to the signer seeds. We need to make sure we always reference it. And then we have to create the data as mutable, update authority as signer, and the collection details. So we're almost there. All right, so next one, what we're going to do is we're going to create that data. So this is going to use a struct called data v2. We're just going to have a bunch of things in it. See, it already tries to set them all. I'm going to set them individually. I'm going to go ahead and skip to the bottom and start doing all these. So true, we want to make sure that it is mutable so that we can change it later. The update authority will be yes, the update authority is the current signer. And then we're going to do some collection details. V1 of size 0. There we go. All right, so we should just have to fill out this data v2 instruction now. So it needs a name. We're going to create these names in just a moment. We're going to just, for now, we're just have an empty one. We'll need a symbol. We're going to need a URI. And then we'll need a setter fee basics points. We're going to set as 0 because we don't care about this in this collection. We're going to have a creators array, or a creators struct, I should say. Well, it's an array of some vec. We have to create a creator. We don't really care about this, but sometimes you might care. This is for like profit share or sharing of fees amongst the creators. We don't actually care in our case, so that's all right. Context.accounts.collection mint.key. We're going to have it verified as false because it's not verified yet. And then share of 100. We don't really care about all this. We're not going to use it. Unfortunately, you have to include it, but we don't care about it at all. The next thing is you have a collection is none at the current time. We're going to change this later. And then uses none. This is also true. Okay, so the thing that we're missing here is it says it doesn't know what creators. Let's go import it real quick. It's trying to import it from there. We don't want it to create from there, so let's make sure that we're importing it from one place. I believe it is just under metadata, so let's make this nice and set up here. So let's see if it exists under there. No. All right, I'm going to be right back. We're going to check where it exists. All right, so where it exists is it's under MPL token metadata types creator. Boom, we have the creator. It's being used. Unnecessary braces, yeah, it's not necessary because we're only using one type as of right now. All right, cool, and that should have everything there. The next thing that we're going to have to do is we have this name, symbol, and URI. Let's go add them as constants up here so we can use this up throughout the program as needed. So we're going to do a constant. This is going to be pub const. We're going to do the name first. This is going to be of type and string. It's going to be, we're going to call it token lottery ticket number. And you'll notice that I did it with no ticket number. This is because we're going to add the number for the ticket later. The symbol, we're going to call this TLT, sure, why not? The constant, this is going to be the ticket constant, so pub, URI, and string. It's going to try to do some arweave address. We're just going to go grab something from the internet. So let's go grab it real quick. So let's just go ticket. And we'll grab a ticket here. So emit, well, this is a nice ticket. I'm gonna go ahead and copy the URL, image address, and put it right here. Oh, that's a big address. We'll figure out that breaks it later. That's fine. All right, so we have all those things. Let's just go set them right over here. So this is going to be name. Guess it has to be toString. This is going to be the symbol, toString, and then finally the URI, toString. All right, let's go ahead and build it, see if it works. All right, so compiled, we must have done everything right. The next thing we have to do, if following our things, is we have to create the actual master edition. So let's go create that master edition. So I'm going to do message. We'll do creating master. Look, it knew exactly what we needed to do next. We're going to have to use create master edition v3. It's going to need a context and a max supply. This max supply will be a sum 0 because we're not going to be doing more than just this account. But let's create that context real quick. So context, whoops, there we go. I'm just going to pull it out so it looks nicer. All right, so another context. So we need a CPI context. This one, once again, new with signer. This is because we have to sign for everything. We're going to do a signer with that collection mint. And so we're going to pull this out. We know that we already have the signer seeds, so we're good there. This is going to be that context accounts.token metadata program to account info. And then this accounts is going to be a create master edition v3 right here. And we're going to need quite a bit of accounts. So first one we'll need is that pair. Is going to be that pair info. Then we're going to need the mint. This mint is going to be that collection mint. So thankfully we already have that. Next one is going to be the edition. This is going to be that master edition account that we've passed in. The mint authority is going to be the collection mint once again. The update authority, collection mint. That collection mint has a lot of power, and that's okay. Metadata is going to be that metadata account. The token program is going to be the one that you pass in. The system program for creating the account. And then finally, rent. I'm hoping in the future that this rent's not required anymore because you actually don't need it. All right, cool. So we've created the master edition. Let's anchor build, make sure we did it right. All right, so we did that. And the final thing, if you remember, is we have to verify that collection. So let's go ahead and verify that collection. So we're going to do a message. Copilot did not get it right this time. Verifying collection. We'll remove all these messages later. It's just going to be helpful for us to understand what's going on. So this is going to be a sign metadata function. It's going to have a context. So let's add that real quick. I'm going to go ahead, go down here, finish it out. All right, so CPI context, once again, as expected, new with signer, because we have to sign with the collection mint PDA. That collection mint PDA is going to be used a lot throughout this whole thing to sign. All right, so program is that token metadata program. So context that accounts dot token metadata program to account info. The accounts, we're going to use a nice little struct for this, sign metadata. It doesn't have all these things that it thinks it has. That's okay. The things it does have is it has a creator, which is that collection mint account as we set up here. So we set up here the creator was the collection mint account. And then we're going to have the metadata account. All right, it was happy. Looks like just making sure my braces all line up. Yep, I'm going to remove this new line because we don't need it. All right, let's build it and see if we did everything correct. All right, so we have everything set up. Let's go build it out. I'm going to add this into this initialize. We're just going to make this a general initialize test. It's not really a test because we're not asserting anything. That's okay. We just want to make sure our thing's working. We can assert it ourselves. If you want to write good code, I would recommend just asserting it if you want to on your own. So I'm going to do it here as well. So we're going to do const. This is going to be a init lottery ix. It's going to have some accounts. So this is not everything. So we'll do dot accounts. It should only have one account, if I remember correctly, because of what we can do is we can actually check what the accounts are required. We can see the pair is myself. We already know who that is. The collection mint, we already know who that is. Collection token, we already know who that is. The metadata account should be derived from these seeds. Same with the master edition. What is not given is this token program because it's an interface. We have to tell what token program to give. So this should just be token program. And we're going to use the, it's going to be token program ID. We can see it's get grabbed from, we don't want to grab it from there. We want to just import it. There we go. Let's make sure it imported from the right place. From Anchor from SPL token. If you don't, I don't remember importing this, but if it's imported, great. If it's not, we'll do it in just a moment. So this is the IX for that. That's all we need, I believe, for that. So once again, we'll just create this instruction or this transaction. So const, this is going to be init lottery tx equals new anchor.web3 add lottery tx. We should be able to use the same information from earlier. I don't expect time to have passed dramatically, so our block hash should still be valid. There we go. And then finally, let's just do the same thing. We're going to go grab this real quick. This should be a init lottery signature, init lottery signature. I'm going to enter so that it looks a little bit nicer. I'm going to take out the skip pre-flight because we don't need it unless something doesn't make sense. I'm going to make this pretty as well. All right, so we have provider connection. We need to make sure that's using the lottery transaction. We have the pair as the wallet up pair. Let us also console log it. So console.log your init lottery signature, and let's run it. So one thing you're going to note is that if I run this right now without doing anything, it's going to try to initialize all of those accounts again. The lottery, token lottery config, a whole bunch of accounts. So I'm going to go ahead and restart the validator with -r. This resets the state so that we can make sure that we understand the state that we're going to start out with. All right, so let us anchor test it. Anchor test skip local validator. All right, so it failed. Let's figure out what we were missing to make it work. So we got a specific error code. This is on the init lottery transaction. So let us do that same trick as earlier. We'll do the skip pre-flight so we can see what is the issue. So I'm going to reset my test validator again and run that test. All right, so we have a transaction with a custom signature or custom error. We can see it failed on that init lottery. Let's go see what that error is. Go to the Explorer and see it failed with invalid program execute. Program account is not executable. All right, so I know what this issue is. This is because we don't have the token metadata program on local. So if we go to this program, we can see this account right here. Count does not exist. We actually have to go grab that from our mainnet. So if you go to Solana Cookbook, you can see here that there's going to be some information on how to dump programs. It's Solana program dump -um, your program ID, and the SO file. So we're going to do that once on our own, and then I'm going to show you a script that will get you all the information that we need. So Solana program dump -um. This is for that specific token metadata program, which is, let's go grab it from the transaction right here. And this is going to be put into metadata.so. Boom, we have the metadata.so. And now if we want to load it, we have to do BPF program. We have to set up, let's just make sure, verify with the code. BPF program, and the SO file. So metadata.so, reset. Now, if we go over to look at this account, it should exist. Boom, it exists, perfect. And it is an executable. All right, so let's run that same test again and see if it works this time. All right, so it passed. Let's go grab that init lottery signature and look at it. Okay, so here's the instruction. We can see a whole bunch of accounts that we've initialized right here. We can see the token balance of 1 because we have 1 token in that new token account. And then there's an instruction, create account, initialize the mint, and create another account and initialize the account. We have mint to it. And then here's our big instruction for, let's see, looks like this is one of the metadata program accounts. And then here's another one. So one of these is going to be the master edition. One of them is going to be the metadata account. And then we set all the authorities. And then this final one is the verify. So this verify right here. So you can see all of our code right here, setting up, creating. It went through and built the whole thing, signed the verify, and our collection is verified. So fantastic. Another thing that we can do, and let's see if we can pull it, is that let's see if we can pull the account. So one of these accounts is going to be our token account. Let's see. So this is our writable one. We can cheat this. Where's the token account? Here we go. Address token. Let's go look at that token, see if it has the little logo. So my fear is realized that random image that we pulled is not showing up here because it had something weird with the URL. That's okay, but we can see the token lottery ticket right here. That's the master edition, has that same TLT. So the URI is actually something else. You can go look at that in the token metadata account. So let's go look at what the URI is supposed to be. There you go. So it's a specific format. So metadata format. So if you go look at these JSONs, it's actually supposed to be a JSON URI, which includes the image. We're not going to do that real quick. You can go based off of the previous collection module and just learn it from there. I'm going to go ahead and pull one that I have. So we'll go grab that from Phantom real quick. All right, so the image wasn't generated because it's actually the URI is supposed to be a JSON file. I just grabbed an example one. We're not going to create one real quick, but this is an example one of name, test token, symbol, test, description, your test, your image, and here's your actual image. So that's why it's not showing up. I'm going to go ahead and generate this on GitHub real quick. So we're just going to create this on GitHub under the developer bootcamp, and I will be right back. All right, so I've created this under the Project 8 token lottery. It's a metadata.json. It has that image that I grabbed from the internet. You can use the same URL. So what you do is you go click on raw, copy and paste that, go into here, update your URI to that specific URL. And then if you go look at now this transaction or this token, you can see the token has a ticket, token lottery ticket hash TLT. All right, so now we can continue. So we've now initialized the lottery. The next thing that we want to do is we want to actually buy tickets. So let's go ahead and buy those tickets. I'm going to just make this should test token lottery, just so that we can do the whole thing in one. This is not necessarily a good test, but it's just so that we don't have to worry about it every time we restart. All right, so we'll get back to this. Let's go to librs and start building out that new instruction. So we've initialized the config, we initialized the lottery. I'm going to go ahead and minimize all these so that it doesn't get in our way. The next one that we have, if we go back to our design, is buy ticket. So let us do that buy ticket instruction. We have to go afterwards. Let's go at the end of this. All right, so pub fun buy ticket. You can see it already kind of generated some code for us. I'm going to minimize this again. There we go, buy ticket. So it's going to have a buy ticket context, and we're going to get started. I'm going to we're going to have an amount. I'm just going to have it buy ticket one ticket at a time, just so that we don't have to worry about this. We can do the amounts on the front end, and that's fine. All right, so we have the buy ticket. Now we need to create the accounts for it. So let's go down here and create those accounts. So it's derive accounts, pub struct, context or buy ticket. That's our context. It already tried to generate a bunch of things for us. I'm going to remove all of them. The only thing that we know we're going to need so far is we need the signer because we need someone to pay for it. And then we're going to need the pub system program because we're going to create a new ticket. All right, so the next thing that we need is we're going to need a new mint for this new ticket. So let's initialize a new mint. So we're going to do account. We're going to have it init again, pair equals pair as usual. We're going to create this as a new seed. It's going to be the specific token lottery number that we're going to use it, which actually in order to do that, we need to do the lottery as well. So let's grab that token lottery real quick. This is going to be a mutable. It's going to be mutable, not immutable, because we're going to be updating the ticket count within it. It's going to have those seeds. Those seeds are going to be B token lottery. And then the bump is going to equal token lottery dot bump. This is so that I can easily derive it. So pub token lottery info. All right, so now we have seeds. The seeds for this one is going to be token underscore lottery dot ticket. It's going to be the number of tickets. So what total tickets. So it's going to be the current ticket number, 2 LE bytes, little Endian bytes. That's going to be bump. And then we're going to be initializing. This is going to be ticket mint. It's going to be once again another interface account of info mint. So we're missing some code here because it's a mint. We have to provide all the information for it. So mint decimals equals 0. Mint authority equals we're going to have this as the collection mint. That collection mint is going to be very powerful yet again. Looks like I'm missing a colon. That is fine. There we go. Mint freeze authority is going to be that collection mint again. Mint token program is going to be that token program. All right, so you can see here, we're already missing some things. We are missing the token program, and so it's probably going to say right here, yeah, missing token program, and we're also missing that collection mint. So let's go ahead and create those real quick. So pub is going to be the token program, token interface. All right, so we need that collection mint account. This collection mint is going to be account is going to be mutable because we're going to increase the number of tokens on it. Well, we're going to use it basically. The seeds are going to be the collection mint account again. So collection mint dot as ref, and then bump. Unfortunately, we couldn't save it because it's not our account. Collection mint enterprise no mint. All right, so we have that. Next, we're going to need a few things. We're going to need a metadata account for our ticket mint. We're going to need that same master edition account that we had earlier, and then we're going to need also the collection metadata account as well. So let's go ahead and build those out. All right, so first off, we have a new account. We're going to do the first one as the metadata account. So seeds are the same as earlier. So let's go grab those seeds. Where do they go? It's an initialized lottery it is going to be right here, not here, right here. All right, so seeds are these. And go ahead and grab all of this code right here. How much should I grab? I forget. There we go. Okay, seeds, collection mint. It's not going to be the collection mint. It's going to be that ticket mint. All right, let's go ahead and grab this. This is going to be the metadata account. So pub, we're going to say is a ticket metadata. Once again, it's going to be created by the metadata smart contract. And the other one that we need is that master edition again. So let's go grab that. You need this so that you can add a NFT to a collection. So instead of the collection mint, it's going to be that ticket mint again. This is going to be the ticket master edition. All right, so that should be right. Okay, so it's already telling us need the metadata program because we're doing stuff metadata program. So pub token metadata program. Token metadata, perfect. Okay, and the next thing that we need to do is since we're buying a ticket, we need a destination. We need a token account to give for this. So let's go ahead and put that in here. This is one thing we're going to need is the associated token account, which we'll do in just a moment. So account, init, pair equals pair. We're going to do the associated token mint equals token mint. Associated authority. This one's going to be the pair because we're going to give it to that person. And then associated token program equals the token program. And then we have to create that specific account. So it's going to be a pub destination equals interface account of type info, lifetime info token account. Perfect. All right, and because we're using the token, the associated token program, we once again need the associated token program set. So let's set it down here. Pub associated token program, associated token. And if you remember when we did the master edition earlier, we also needed rent. So let's add that real quick. Boom. All right. So that should be everything for buying tickets. Now let's actually write the code to buy the tickets. Go back up here. And let's get started. Before we get started, let's actually do an anchor build just to make sure we're doing all right. All right, it passed. It just had a warning because we have a context. That's okay. So first thing, I'm going to get that clock so that we can tell if whether or not someone can actually buy a ticket. So now we have the clock. Then we're going to get the ticket name. Just so that we make sure that we set the ticket name. This is going to be name. We're going to do a little bit of string concatenation in Rust. This is going to be plus context.accounts.token lottery.total tickets.toString as string. Boom. And now let's check. So if clock.slot is less than context.accounts.token lottery. This is going to be lottery start time. So the lottery is not ended, or clock.slot is greater than the end time because we don't want anybody buying after it ends. We want to throw an error. We'll go at lottery not open. You can see here we already have an error code, so that we need to actually create those error codes. So let's go down to the bottom and create those error codes. So the way that you create error codes in Solana programs or Solana smart contracts is you use the macro error code. Pub enum, you can see it actually already knew. Lottery is not open. It's a message. That's the message. There's our enum. All right, so let's scroll back to our code. We have the ticket name. We've done the clock slot. Check that someone is eligible to buy the tickets. Now we actually have to do the buying of tickets. So if you remember, there was a price to pay whenever you do the ticket. So we're going to take that money from the buyer and deposit it into our lottery pot. So CPI context, this is going to be new because we don't need any PDA signatures here. We're going to do context.accounts. This is the system program. .to account info. we're going to have to do system program : transfer. Whoops. There we go. All right. So it's going to be from the pair to the token lottery. It's not the authority because that would be myself. It's going to be the token lottery. It's the token lottery count itself. And the lamp ports is specifically the token lottery price. That is not in this section. It is actually outside of the transfer. It's down here. And it's actually just the lamp port amount. There we go. All right, so we've done the transfer. Next thing we need to do is we need to create the ticket. So as earlier, we're going to do a lot of the same thing. We're going to do let signer seeds. It's not going to be token lottery. It's going to be the collection mint because we have to use the collection mint authority to create a bunch of these, a new ticket off of this collection. And we have to mint the new token. So mint 2, once again, CPI context, new with signer. We're going to just enter a bunch of things real quick. There we go. The program signer seeds are a reference. The program is going to be a context.accounts.token program .to account info. Then we're going to use the mint 2, the same one as the last time. And we're going to mint to, the mint is going to be, let's just set all that. It's a ticket mint. We're going to mint it to the destination. And the authority to do that minting is going to be the collection mint. Perfect. All right, so let's see all the errors that we have. So first off, I realize that this needs to be bumps because that is the current way that you grab the bump. And see that mint to instruction. So I'm missing something in the instruction. We're missing the amount. That's okay. Very easy fix. It's going to be comma 1. There we go. So we minted a single token to the ticket of the ticket mint. Next up, we're going to go create the metadata accounts and create the master edition. I'm going to go ahead and grab that from the token lottery and we'll just update it as needed. So these two right here. I'm going to copy and paste those just so to save us a lot of time. All right here. And the first one we need to go through is this one, the create metadata accounts. We need to make sure that it's all set up correctly. So the correct one should be ticket metadata. The mint is the ticket mint. The mint authority is the collection mint. That's correct. The pair will be the pair. The update authority is the collection mint. System program rent perfect signer seeds. Our name, our string. This is actually going to be our ticket name because we want to have our ticket name be the one with the number. Let's see. Okay, so seller's fine. Address is going to be let's see, this is the creator's address. We don't actually have any creators for this one, so I'm going to go ahead and remove this and put none. True, and then this is going to be none because it has no collection details. This is just like, if you remember from the token metadata information, the specific mint account has none. All right, so we have that one. Next up, we have the master edition. So let's go ahead and start creating it. So this one, the first thing I know is this is going to be the ticket mint. The master edition is going to be the ticket master edition. Once again, also the metadata is ticket metadata. And let's go down pair. Yep, the mint is the ticket mint, ticket master edition. The mint authority is the collection mint. Update authority is collection mint. Metadata, token metadata. Yep, rent, everything good. Sum is 0, perfect. Now we need to actually verify this as part of the collection. So set and verify side collection item because we're adding a new collection item. We're going to go ahead. This is the authority record. We remember earlier we set it as none. So we're going to set it as none now. And I'm going to make this a little bit prettier. Enter, enter, enter. All right, so we need a new CPI context. Once again, it's new with signer. So new with signer. Let's see if it did everything. That'd be fun. So it needed to be a token metadata program. Perfect. Set and verify size collection item. That is correct. Now we're missing a bunch of the different items, so let's just fill that in. So the first one is the metadata. This is just going to be the context.accounts.ticket metadata.to account info. Next one is going to be the collection authority, which is that collection mint. The payer is going to be the payer that we're used to. We're going to have an update authority, which is going to be the collection mint again. We're going to have the collection metadata. Context.accounts. Do we actually include this? Maybe did we forget something? I think we forgot something. That's okay. Let's go at it. Two of the things that we missed two things. I just double checked. We missed the collection metadata and the collection master edition and collection metadata. So we're going to copy and paste this. We're going to change a couple things. So this is going to be collection metadata, and this one down here is going to be collection master edition. And then we just need to change these to use the collection mint account. There we go. All right, go back up to our code. So collection metadata should be now collection metadata.to account info. The next one, I believe it is the collection master edition. So collection master edition, which is our collection master edition. And let's make sure I have everything. So looks like you don't. Let's see what I'm missing. I'm missing so I'm not importing it. Let's import it. Let's do this one. Let's make sure it imported in the right place. One thing I don't really appreciate is it's putting it all here. I actually want it to all go up here. So let's go pull it out and put it up here. So create master edition. Just going to clean this up a little bit. It's adding it in a place I'm not exactly fond of. This is why you don't do autocomplete sometimes. So let's go and copy and paste this whole thing into here, and then just update it as needed. Pull it out. All right, let's see if it added everything. Whoops, I put an extra character. That's okay. All right, so where is it? Set and verify collection. Looks like I'm missing something. Missing collection mint and collection metadata. I added an extra thing, and then we need the collection mint. So collection mint. As expected, collection mint, and it's all happy. All right, so we've done all this. Now that we've created the ticket, we need to increase the ticket number by 1. There we go. All right, so we have everything. Let's test this. Let's see if it works. Looks like there's some errors. Let's just remove these and get them working before we start, because otherwise we will run into errors later. System program / transfer. This is just us needing to include the system program. So use anchor _lang system program. Now let's see if we're missing anything else. Looks like we have everything now. Looks like everything is happy. Yep, everything seems to be happy. Let us now anchor build it. So built correctly. Now let's go buy our tickets. I'm going to go ahead and create another function for this just so that I can make sure that I buy the tickets. I can buy multiple tickets very easily. So buy ticket. This is going to be a new function. We're going to buy all those tickets. So const buy ticket ix equals await program.methods.buy ticket. And then it's going to be .accounts token program ID instruction. Now we have to get that block hash with context again. We are going to have to get some information. We're going to have to create a new transaction. So this is going to be new anchor transaction. We're going to do the same thing we did earlier. There we go. All that code right there. Add by ticket instruction. And then we need to just const signature, send a confirm our transaction, and console log it. This is going to be the buy ticket signature. And then we have to actually call it. So let's go call buy ticket over here. Await buy ticket. All right, so we have our test. Let us kill our validator, restart it, and buy our ticket. All right, so it failed. And we meant it to fail, actually, this time. So let us see program failed to complete. This is on the send and confirm, the buy ticket instruction. Let's add our pre-flight instruction so that we can still get the pre-flight parameter, so we can still get the signature and try this again. So I'm going to kill this. Actually, it should be fine. No, okay, I have to kill it first, and then we should be able to run it. And what we should see is that there should be an issue if we did everything right with the program, which I might have done a typo here and there. We should have the signature tell us that we'll hit a limitation. So let's go find out. So if you go over here to our localhost explorer, you can see it failed. We go all the way down to the logs. We exceeded the CU meters. So we did, seems like we did everything right in the program. We'll figure that in a moment. But we actually exceeded the amount of CU required for a base level transaction. We hit 200,000 compute units. So this is a great little teaching opportunity right here. Because we hit the compute unit limitation on a single transaction, we actually have to increase the compute limitation. So let's create two instructions to do that. So this is something that you will normally do within your Solana development. You will normally create different compute instructions and priority fee instructions all the time. So if we do this compute instruction equals anchor.web3.compute budget program, program, not instruction, dot set compute unit limit. There we go. We can set a compute unit limit of, let's make sure I do that right, of, well, let's set it as, so we hit it at 200,000. Let's just set it at 300,000. We can update this later as needed. I'd actually recommend, and this is very important, I would recommend updating this units to be as close as the amount of compute that you need max for your transaction ever. This is so that you don't have to worry about this and you don't make your users pay more. All right, so we also need the new priority because we're using a compute budget program compute instruction. We also have to create the priority. So compute budget program set. This is going to be set compute unit price. And our price is in microlamp ports. We're going to just set it to 1. Normally, you're going to have to set it to something else or be dynamic with it. Because we're in a test and only one environment, we're fine with this. All right, so now let's add everything, all of our new instructions that we've just added. Perfect. All right, let's run it. Let's restart our validator and run it. All right, so it passed. Looks like our buy ticket signature passed too. So let's go look at that real quick. I'm going to go click on this, and you can see here, got a new ticket. Let's go look at that token account. It's ticket number 0 because we count from 0 because we're comp science people. And it did all the work. So it set it and verified a collection, did a clean write to the collection metadata, and added our new ticket to the collection. So that's all the work that we've done to create the collection, add a new ticket to the collection, have someone buy it. Now, the next two things that we're going to do is we're going to do something with a smart contract called switchboard. We're going to do a commit reveal function to create randomness and use it within our smart contract. Be great. I'm looking forward to doing this. Let us get started. So I'm going to minimize these buy ticket things because we're going to go into a whole new function. Let's actually go down here. Oh no, I can make this faster. Let's minimize it. I'm going to enter here a few times, and we're going to create two new instructions. You can see here we are 3 in. These 3 are going to be a lot faster, thankfully. These are all the setup ones. All right, so pub function. We're going to call this one. This is going to be commit randomness. All right. Let's try to do some things for me. I don't care for all this. Let's just remove it all. Have a base context one. Underscore context because we're not going to use it immediately. And let us create that struct. So this is going to be a new context. So I'm going to create it right here. So derive accounts, pub, struct, commit randomness. And then I'm going to have nothing in there. And we're going to, let's see, it's not going to like it because I had nothing. We're going to add a few things. So we know that we're going to need the token lottery. And so we need to be able to update that. Account. And this is going to be mutable because we're going to be updating it. So mutable, I'm going to go grab the seeds from it real quick. So our seeds were right here. Seeds and bump. Bump equals token lottery.bump. And I'm going to build this just to make sure that we are doing everything correctly. All right, so built, perfect. So there's 2 things that we're going to do. One thing that we're going to do right here, and then we're going to do the second thing later. We're going to have a randomness account. We're going to create that. This is going to be an unchecked account because it's actually going to be managed by Switchboard. It's not by us. So this is managed by the randomness smart contract. This is specifically Switchboard. And then we're also going to need because we're creating an account, we'll need the system program. And finally, we'll need a pair for this. So this is going to be account mutable of pubs pair signer info. Perfect. So those are actually all the accounts that we need. So let's go back to our function, commit randomness, and get started with it. So before we do any commit randomness, we want to make sure that the clock is done. We want to make sure that the lottery is done, is what I should say. The clock is past the lottery time. Okay, so the first thing that we're going to do in this commit randomness thing is we're going to get the clock, because we're going to need the clock to make sure that we're setting the randomness information correctly. The next thing we're going to do is we're going to grab the token lottery account because we're going to have to do some checks to make sure that we're doing everything correctly. And then the first check that we're going to have to do, I believe it's the first check that we're going to have to do on ourselves is we're going to have to check that the accounts pair, so accounts.pair.key, if it's not equal to the authority, we want to throw an error that this is not authorized. Now let's go create that error real quick. So we'll go down here and we will enter not authorized. So we have that error code now. This is because we only want the people that are authorized to commit the randomness. Otherwise, someone might do something funky. We don't know. All right, so context dot was, because I have the underscore. There we go. Fix that. And the token lottery, the token authority, this is because it doesn't need to be, there you go. All right, doesn't need to be referenced. Okay, so we have the pair checked. The next thing is we need to grab the randomness data, and we need to use something called from switchboard to do this. So let's go add switchboard to this real quick. So switchboard's crate is just cargo add switchboard on demand. So we're grabbing the crate. We'll be right back in a moment. Okay, we're here. We have the crate. Now we can actually use it. So what we're gonna have to do is we're gonna have to check this randomness data is what we expect. So let randomness data equals randomness account data, and we have to parse it because we need to make sure what's going on. So accounts dot randomness account data as ref. We're going to have to do this. Actually, we're going to borrow it and unwrap it here. There we go. Okay, so we have the randomness data. Let's see what's the problem. It's because I don't have the type for it. So we have to go up here. We're going to just import it real quick. So use switchboard on demand accounts randomness account data. Okay. Let's see. It's not being used. It's probably because I misspelled something then. Randomness account data context.accounts.randomness. There we go. Looks like everything is happy now. So we have randomness data, and we have to check that the slot is valid. So if randomness data dot seed slot is not equals to clock dot slot -1, we need to return an error. Error code randomness already revealed. .into. This is because if the randomness data is already, like, we're past the slot, basically, it's already revealed. So we make sure that we're not revealed, because that would be bad. Otherwise, someone can know exactly who the winner is. That would be really bad. So let's go add that. Randomness already revealed. Randomness already revealed. Okay. So let's see, is error. It is just ERR. All right. So now that we've set all that, let's go set that in the token lottery. So token lottery dot randomness account equals context dot accounts dot randomness account key. Okay. So we have the commit randomness. We have everything here that is required for it. Now, there's a few things that we're going to need, and it's quite a lot of things, actually. Now that we're using Switchboard, we have a new Switchboard program that we're building, or that we're using. We're going to have to make sure that we add all those, just like we add the specific metadata program right here. And there's a lot of different accounts that you need. I've made it easy for us to develop with it. If you go under to Project 8 Token Lottery Setup, there's going to be two separate SH files. All you have to do is go into it, copy and paste it, and create your own SH file. So I'm going to do this right now. We're going to create a bunch of things here. So I'm going to go make a new directory. This one's going to be called Setup. And go into Setup directory. This is just going to be just like how this is set up. There's a Setup directory. And we're going to create in that directory. I'll stop doing the stuff all in the CLI for just a moment. We're going to go into that setup directory and create two files. So this is going to be setup local.sh, and then I'm going to copy and paste that from the setup local file. And the other one is going to be the setup start validator. This is just going to have that really long command that we need to set up all the accounts. All right, so in the next one, so start validator. All right. So we have both of these shell scripts now. You can look at them if you want. I would recommend always looking at and checking it. I'm going to make them executable of chmod setup local and chmod +x start validator, and then we're going to run them. So set up my local. This is just going to download all those accounts that we need from mainnet. Now note, you should only have to do this once. If you run into some errors that were unexpected throughout this, you might need to do this again. It's all because like the randomness accounts might expire, and that should be fine. All right, so we have all the different randomness accounts. Now we can just run start validator. We'll just run this again over and over. This just will grab all the accounts that we need and start it in our local validator. All right, so next thing we're going to do is we're going to actually run our script. So I'm going to buy a couple tickets just because I want to make sure that I have a lot of tickets later so I can test some things. All right, so we're going to buy a bunch of tickets, and now we can do all the different things for running this commit randomness function. So the first thing that we're going to need is we're going to need the queue. So the way that switchboard works is there's kind of like a queue of randomness accounts, and it goes through this queue and it gives you this randomness data. So I'm going to set up this queue, new anchor.web3.public key. This is going to be a specific value. It's going to start with, if you go to, I'll show you how you actually figure all this out. So go to switchboard on demand, their code. So this is their randomness code right here. This link will be in the GitHub repository. If you go to their specific, I believe go to their index, they're going to have a whole bunch of code here. You'll see it. It's very similar to what we're about to do. And if you go to their utils, they'll give the specific, let me make this bigger for y'all. They'll give the specific queue thing. We're going to work with the queue from mainnet because we copied it from mainnet. So let's go ahead and copy and paste that account. All right. So this is going to be the queue. The other thing that we're going to need before we start doing anything else is we need to actually pull the specific code or the program to run with a switchboard program, because we're going to do a bunch of things to set this up in the JavaScript side. So let's go ahead and do that. So we have this switchboard program. I'm going to do a let switchboard program for now, and we're going to update that in a moment. We're going to need this later, so I'm going to go ahead and create it. This is going to be a randomness key pair. So anchor.keyPair.generate. And then we're going to create the specific, we're going to grab switchboard. So if we go, we're going to do a before, and this before is going to load the switchboard program. Load switchboard program. That's going to be an async, perfect. All right, so we have the before. This what it's going to do is we're going to do const. We got to grab that switchboard IDL equals await anchor.program, capitalized program, fetch IDL, and we have to fetch it from the switchboard specific program. So we have to include switchboard from here. So let's do a npm. Is this the right place? It should be in the thing. So npm add or install at switchboard dash switchboard dash xyz slash on dash demand. This is switchboard's nice package for this. At switchboard on demand. Perfect. So the ID is going to be switchboard on demand. So the switchboard on demand PID, that's the program ID. And then we need to set the connection. So this is actually going to be from mainnet. So connection new anchor.web3.connection. And then the provider or the URL we're going to use is going to be mainnet. So if we set this real quick, I'm going to make sure I remember. We're going to set this to the mainnet URL. So I'm going to go grab the mainnet URL real quick from the Solana docs.com/docs. And this is going to be the RPC URL. So let's go grab that. So mainnet RPC is going to be under that public endpoints. So let's go grab it. Here it is right here. Put that right there. And now we have the IDL. So then we can do switchboard equals new program using the switchboard IDL. And let's see, make sure I did everything correctly. Program, new switchboard should be the provider, not the PID. Provider, because we're grabbing it from our provider. All right, so this error right here is just because it's saying like, hey, this might not exist. We want to make sure it always exists, and that's okay. So I'm going to go ahead and put that as anchor IDL, and we should be fine. So as anchor.idl. All right, everything's fine. This should load that program so that we can use it later. Now what's interesting is we can actually save this to a JSON file, and we're going to do that in just a bit so that we don't have to constantly load this over and over. So I'm actually going to go grab this ID, and we're going to pull it out and set it as a JSON. So be right back. All right, so I did some quick coding. All I did was I used FS to save that switchboard JSON to my file system. That way I don't have to do this over and over again. Now what I can do is I can just grab that IDL and just be fine. So the switchboard program, we're going to just make it that a const instead. I'm going to go ahead and comment out this code. What I'd recommend, I'm not going to put this JSON file in here because it might change, but always try to get it again later. So we're going to do new anchor.program. This actually says that the switchboard on demand IDL exists. It doesn't look like it does, so that's okay. We're going to have to import this real quick. So just like we did the target types token lottery, we're going to have to do import switchboard IDL. So switchboard IDL. This is going to be from that file that we just did. So I saved it to switchboard.json. And let's make sure that it said it updated correctly. Switchboard IDL, switchboard JSON not found. This is because we are in tests, so it needs to go backwards. So backwards, and there you go, it found it. All right, so we have switchboard JSON. This one's going to be as anchor.idl, and then it's going to be the provider. Let us make sure we did everything correct now. I believe I did everything correct. We should be able to just anchor test it. Since I've run this test before and I haven't restarted the validator, we expect the test to fail, but I don't want them to fail on this switchboard program. Let's see what happens. So it did fail, perfect. And it failed on commit confirm transaction. So now we have the switchboard program, perfect. All right, so I'm going to remove all this extra code. Whoops, didn't remove all of it. There we go, from top to bottom. And now we can start testing our commit reveal function. So we've reloaded the switchboard program. We have to go all the way down here with our queue. We have to start doing things with this specific queue. All right, so we need to go grab our queue account now. So queue account equals, this is going to be new switchboard.queue. And this is going to use that switchboard program that we used earlier and the queue that we just pulled. All right, so the next thing we need to do is we need to get the queue account. So we're going to do const queue account equals new sp.queue. This is going to be with the switchboard program and that specific queue that we have right above. There we go. And we're going to do a quick try catch. There we go. Let's just console and we'll do a process exit. so that we can see what the error was. We don't want to continue just in case something went wrong. And then here what we'll do is we will do await queue account dot let's load data. That way basically we're loading the data into the queue. All right. The next one we're going to do our create randomness and do our commit reveal. So const randomness create randomness ix equals await sp dot random randomness dot create. This is with the switchboard program, the RNG KP and our queue. All right, looks like, oh, I forgot a equals. That is fine. There we go. And then we got to create our instructions. So create randomness. Well, first in transaction. So await SB as V0 transaction. Connection. We got to do the provider dot connection because it's our current provider. This is going to be our IXs, which are just going to be our create randomness IX. These are instructions. Pair is our current wallet, right? So wallet, not pair, but public key. There we go. And finally, the signers are going to be that wallet.pair plus the RNG key pair that we created. All right. So the next thing that we'll have to do is we have to send the transaction. So const create randomness signature equals await provider dot connection dot send transaction with our specific create randomness transaction. There we go. And let's just console.log create randomness signature so that we can see what the signature is. All right, so let us restart our validator and do our anchor test. Oops. So anchor test skip local validator. There we go. And see what happens. All right, so it passed. Let's go grab that signature. So here's the create randomness signature. We'll go back to here. We're going to open Explorer as usual. Go make sure it's on local. Go to that signature, and we can see here we had our transaction. It was using, so we did the compute limit. That's our program, create. We got the account size for the immutable owner, or sorry, for the token program. We did a create account, initialize. So here's a address lookup table thing. This is for our something that we did in the switchboard program. So it's allocating, it's assigning. So this will allocate, assign, and transfer. This is looks like this is about what we did for our queue account. So there we go. All right. So we have our that one worked. All right, so the next thing that we need to do is we need to actually do that commit so that we can commit this randomness to be later revealed. So let's go ahead and do that. All right, so we do const commit. We're going to create that commit instruction. It's going to be await program.methods dot commit randomness. This is that commit randomness instruction that we created earlier. We're going to have only that account that we just created, so that randomness account, randomness.public key. There we go. And we're going to make sure that we pull this instruction out. All right. And then like before, we're going to do const compute ix. This is we're going to call it a commit compute ix equals anchor.web3.compute program. There we go. And we're going to have to set the units. Let's set it to 100K. I don't think it's going to need 300K. Then we're going to need that priority fee. So this is going to be the commit priority IX set compute. This is not compute unit price. Oh no, it is compute unit price of microamperes. We'll set it as 1. We're working on local. That's okay. And then we're going to get that block hash. So commit block hash with context. So wait, get latest block hash. And then we have to create that instruction. So const commit, or the transaction. So new anchor dot web3 transaction. It just filled in everything. Let's see what it filled in. Fee pair, provider, wallet, public key with the commit, the block hash, and the last valid block height is that. And it just added our IX. We actually need a little bit more. So we need to add this IX. Whoops. We need to add our new the compute priority, computing IX, and then finally the commit priority IX. And there we go. So we have commit, the compute budget, priority, commit IX. We also need the SB commit IX. So add SB. Oh, so we didn't actually create the switchboard commit, so we have to also create that. So commit IX. This is because we created our randomness account with that create randomness signature. We need to also make sure the switchboard program is using that randomness account to commit for it. We need to provide this in the same instruction that we do the commit on our actual program. So this is going to be switchboard commit IX equals await our specific randomness account commit IX with our queue. Perfect. So this needs to go before our new commit IX. So I'm going to put it right here, right beforehand. Whoops, not that one. It's SB commit IX. There we go. And don't have a semicolon. There we go. So we have our 4 instructions that we need. And now we just need to send and have a signature. So commit signature. What we're going to do is send a confirm transaction. It's going to be provider, our commit transaction. We're going to have our, so commit transaction, wallet payer. I'm going to have skip pre-flight on, or sorry, skip pre-flight not on, because I just want to get the signature. And then we just need to console log it. Commit signature. There we go. I just realized I have to restart the local validator. So always remember to do that. So restart it and then run it. All right, failed. So let's figure out why it failed. Should test, cannot read properties of undefined of key. This is for queue. Looks like I missed something on the queue. Let's go look that up real quick. All right, so I figured out what the issue was. So what happened is some of my accounts, they expired. If you actually dig into the code for Switchboard, they expire after, it was like 6 hours. So mine have expired. So what you kind of do is just do setup local. You run this and then you restart your validator. So let's just do that real quick. There we go. Start validator. And then that should run it. And then let us anchor test skip local validator. And now, as long as it doesn't like exceed the test timeline, this should pass. All right, let's see what the failure was. Account does not exist or has no data. So try to pull some account. Let's just make sure that, yep. So I'm not actually setting it. Let's run this again just to make sure. All right, so the issue that we ran into where it's failing is actually because this send transaction didn't wait for it to confirm until we moved on. And since this is using a special type of transaction, it's called a version transaction, we have to do a little bit of extra work in order to check it. So we're going to do this real quick. We're going to do a let's call this confirmed equals false because it's not confirmed yet. And while, it's going to be simple code that we probably write in our college days. I don't want it to throw, let us take that out. We basically just need to check if it's confirmed. So const confirmed randomness equals await provider dot connection dot get signature statuses with our create randomness signature, and then so randomness status, we need to pull that specific status out. This is not quite right. Let's just remove that extra code right there. So it's dot value, because it will be 0 because it's the only one that we send back. If randomness confirmations is not equal to null, so not undefined, and the randomness confirmation, let's do randomness confirmation status is equals to confirmed, then we set confirmed equal to true. So let's clean up some of this code. There we go. And clean that up a little bit as well. All right, so if confirmed equals true, then move forward. If not, continue looping. There we go. All right, so let's kill this validator, restart it, start it here. Whoops. There we go. And so this should always work now, because what it's doing is it's now waiting for that transaction to be confirmed before it does the overall commit transaction that we just coded up. There we go. And sure enough, it got confirmed. So one thing that you also note is that our time has increased dramatically. What you do is you just add a timeout. I've made it a very large timeout. The real thing that you would want to do is like separate these tests, but because we're just doing one large integration test, it's all right. So now we've done that. We've done the commit. Now we actually have to code up the reveal. So let's go back over to our smart contract code. Let's start writing up the reveal instruction. All right, so we're going to create first the derive accounts. So the accounts that you would need for this specific reveal instruction. So this is going to be, we're going to call this reveal winner info. There we go. So what are the things that we need for revealing? There's a number of different accounts that we're going to have to consider. Things like the commit account. We're obviously going to need the pair to do things, but overall, what we need is, so let's start writing that actually up. So first we need that pair because there's going to be some money being used. The next account that we're going to need is, it figured it out already. We're going to need the token memo, or sorry, the token lottery. So there we go. There's our token lottery. And then finally, we need the randomness account that we're using. So this is going to be an unchecked account because it's going to be created via the switchboard smart contract. That's okay. It's every time you use an unchecked account, you should always have some red alerts going on and make sure that you know what you're doing when you're using this. I know that this account is being created and checked by the switchboard smart contract, so I'm okay. All right, so we have the reveal winner accounts. Now let's actually create the instruction. So we'll do pub function reveal winner. We have to create that context with the context that we just wrote. So this is going to be with that reveal winner context. And then we don't need anything else. So we're going to do outputs, the same thing as usual. We do outputs a result. There we go. And we know that it's going to give an OK at the very end. Oh. All right. I'm going to just go ahead and do an anchor build while I code the rest of it, just so that if I run into any issues, this will tell me very quickly. Let's see. All right, looks like we didn't run any issues, so let's start writing it. So first thing, we're going to have to check the clock. So get the clock. Then we're going to have to do let token lottery and get our specific token lottery account. We need to make sure that the token lottery account, so accounts.pair.key that the person who is doing this or revealing it is the specific authority of the token lottery, because otherwise we want to return an error code of not authorized. We don't want someone revealing that they're not allowed to. And the next thing that we need to do is we need to make sure that the specific account, is that right? What am I doing right there? Context.accounts. Let's see, something is missing there. Similar name for context. Let's see, context.accounts.pair should be right. Dot accounts. All right, sure. Context.accounts. We need to make sure that the randomness account is the same randomness account that we set earlier in that token lottery config. Otherwise, we need to exit because that is a problem. It's avoiding someone setting a new randomness account and hijacking it based off of a randomness account that creates a good random value that will make them win. We want to make sure that it's set before everybody buys tickets. The next thing that we need to do is we need to check that the end time is set. Otherwise, the lottery is not completed. And then the last thing that we need to do is we need to also require, this is another way that you can do these checks. It actually, I think it's kind of cleaner. We need to require that the winner is not chosen, because if the winner is already chosen, then what are we doing? Why are we trying to overwrite with a new winner? Otherwise, we can accidentally create more winners overall. All right, so random is data. We need to grab that randomness data from the randomness account data. So we're going to have to parse it. This is grabbing from the context accounts randomness account data borrow. This is so that we can actually get the information out of that account and that we know what to do. So we're going to get that revealed random value. Whoops. There we go. And it's coming from that randomness data dot get underscore value, and not the clock. Well, it is the clock, but it's a reference to the clock. Otherwise, you can't make good Rust code. Then what we're going to have to do is we're going to have to make sure that we handle an error of, if there is an error, you need to make sure that our randomness is not resolved. So say that someone's trying to reveal this winner in the same instruction or same transaction that they're committing, we should fail because it must be that clock plus 1. It must not equal, basically. So next thing we need to do is we have the revealed random value. We need to create the winner. So the winner equals revealed random value of the first random value in that array. And we're going to do we're going to make it as U64. And we're going to do some basic math that we are used to in computer science. We're going to do it over the total tickets. So we don't want the revealed value to be larger than the total ticket amount, because then we just run into issues. So now we have the winner, and we need to make sure that we set the winner of our token lottery, and we need to say the winner was chosen equal true. And that is it. That's everything that we need for the specific token lottery, revealing the winner. All right, so let's do an anchor build and see if it runs. All right, so we've done that. Now let's go over to our test and start writing that test again. So after the commit, we want to now use our new reveal winner instruction. So reveal winner ix equals await. Now this is not going to be all the code. Thanks Copilot for trying, but not quite. It's not the program ID, but we're going to need one account set here, and that is that randomness account. Otherwise, it won't know what randomness account to use. The next thing that we're going to have to do is we're going to do what we did before. We're going to have to create a reveal block hash with context, and then const reveal tx equals new anchor transaction. Then we have to set the actual variables just as before. There we go. This is that fee pair of the provider using the specific things in our reveal block hash with context. There we go. And we have to add we have to add two things. We have to add the reveal winner IX, and then there's one other thing that we haven't done yet, is we actually have to call switchboard and make it reveal as well. So right before we do all this, we're also going to just do a const sb reveal IX, and we're going to reveal that specific randomness off that account. So we have to do that first, otherwise it doesn't know what to do. So let's add that. So this one is going to be add reveal IX and then add the specific reveal winner. Let's just clean up this code just a little bit so it's a little bit more readable. There we go. So now we have the reveal transaction and we need to just send it. And one thing to note is you cannot send the reveal transaction so close to the slot that it was committed in. So we need to make sure that we're not going to reveal it too soon. So we're going to set the current slot, and then just like before, we're going to do while current slot. Sorry, we don't want the slot to be before the end slot. So there we go. We're going to just do a const slot equals await get current slot. If slot is greater than current slot, then current slot equals slot. Whoops, there's a lot of extra code there. And then we just need to finally do console.log. I'm going to just log the current slot just because I want to know what's going on. All right, so what this is doing is waiting till the end slot, and it'll just continue on until the end slot is hit. And then once it's hit, we'll be able to do this reveal because we can only do the reveal after the lottery is ended. All right, so let's do const reveal signature equals await anchor.web3 send and confirm provider connection reveal transaction wallet provider. And then let's console log it. Perfect. All right, so we have the console log. Now let's see if it runs. So I'm going to go ahead and kill this. And let's also check, make sure that if my memory serves correctly, we want to make sure that our configuration that we set early on is not going to be too crazy. So this initialize config needs the start end. It looks like that we did the current slot plus 20. So we should be okay. I just wanted to make sure I didn't set the slot too high. Otherwise we'd be waiting forever. All right, so kill the local validator, rerun it, and then we're going to run this test. So let's go ahead and run it. Whoops, that's anchor build. Might as well let it build. All right, let's run the test and see what happens. So you can see it did some work on the slots and then it eventually did a reveal. So let's go look at what that reveal looks like. All right. So if our memory is correct, we can see here, this is the switchboard program and it did a create an account, and this is our program. So we can see that it did the randomness reveal on that switchboard program, and then it revealed the winner on ours. And there you go. We have the winner. Now what we need to do is we need to make sure that we claim the money out of that account. So we have a winner, and let's just add a little bit of code to see who that winner is. Otherwise, we won't be able to see who actually won. So I'm going to go ahead and in here, we're going to add a log real quick. So message, we're going to set that winner, and I want to see who that winner is. So let's go ahead and kill local validator again, restart it, and then run our test and go look at that in signature. All right, so let's grab that signature that we just created, paste it. Let's make sure okay. Let's paste it in, boom. And let's go look at the logs. So our winner was chosen as 3. So the third buy ticket out of all the buy tickets we did up here. So we did a whole bunch of buy tickets right here. The third one, I think we're counting at 0. So the fourth one will be the winner. So there we go. We have a winner and it's within our range of all our tickets. All right. So now we have the winner. It is set. Let's actually write the code to do the claim now. So I'm going to do some cleanup real quick. We revealed. I already revealed. We have this token lottery. Perfect. bunch of error codes. Okay, so we're going to do the normal thing of we're going to derive the accounts pub struct, and we're going to call this claim winnings with the right caps, winnings. Perfect. And so we know that we're going to need, as usual, we'll need the pair, so pub pair signer info. The next account that we're going to need quite a few accounts, because what we're going to have to make sure that we do is we have to grab the ticket account. We have to check that the ticket belongs to the specific collection that is set within our config. And then we have to actually release the funds. So we have to also account for that account as well. Lots of accounts. So let's start listing them. So the first one that we're going to have to do, so count. First one is going to be our token lottery, because that's an easy one. We don't have to really think about it. There we go. So this is pub token lottery, count token lottery. The next one that we're going to have to do is we're going to have to grab the ticket mint. This is a specific ticket that the user has. So let's do mutable. Actually, it's not mutable because we don't need to change it. But the seeds are, we have to make sure that it equals the token lottery winner seeds. So this is the third one that we saw earlier. It's going to be different every time, but in the previous example, it was third. So pub ticket mint. This is an interface account. Info mint. Because we have that mint, we know that we're also going to have the specific, we're going to have token program. So let's go and put that there. So pub token program. This is going to be an interface of token interface. All right, so we have the ticket mint. The ticket mint belongs to a collection that we're going to have to check. So let's do that one as well. There's lots of accounts. So this is going to be the collection mint. So seeds equals, this is going to be that collection mint seed. So B collection underscore mint as ref bump. And this is pub collection mint interface account mint. The next one that we're going to need is we're going to need some accounts from the token metadata program. So before I do all those, I'm going to go ahead and put down here the token metadata program. So pub token metadata program info metadata. Metadata is the type for the program, right? The struct for the program. All right, so let's go ahead and grab those accounts now. So, whoops. Account. We're going to first grab the ticket metadata. So the ticket metadata account. So seeds equals, this is going to be metadata, token metadata program as ref, and then the ticket mint key. So it's specifically the metadata on the ticket mint. So then the seeds come from the program of the token metadata program. There we go. And this is going to be pub ticket metadata. This is not an unchecked account because we know it's already created, so we don't have to do anything special with it. So this is an account of type info, comma, type metadata account. There we go. And then the next one that we have to do is we have to check the winning ticket account. So we need to go check that associated token account real quick. So let's go grab that. So account. This is going to be seeds equals, let's see. Oh, sorry, not seeds. We can just use the special things from associated token. Mint equals the ticket mint. Associated token authority equals the pair. So it's owned by the person who is sending this instruction. And then the token program is of the token program that we expect. This is the ticket account that we expect. We're not just using an account, we're going to use an interface account. There we go. And then finally, we need the collection metadata. And the reason being is we need to make sure that this ticket mint belongs to the collection metadata that we set. So count. And then these are seeds. Let's see. Yep, it knows exactly what we're going to do. The metadata, token metadata program, and the collection mint. The seeds are from the token metadata program. And pub winning, collection metadata equals the specific account info metadata account. All right, so we have everything here. Now we actually have to write the claim instruction. All right, so let's go ahead and write it. So we're going to do pub function claim winnings of context of our claim winnings context. We're going to do the same thing as we usually do. Outputs a result. And we know the end of this code is always the same. There we go. Let's make sure I spell claim right. Otherwise, we're going to run into issues later. Okay, so first thing we need to do is we're going to require that the context.accounts.token lottery winner chosen. So if the winner is not chosen, we want to exit out. So we want to make sure that the winner is chosen before you claim the winnings. Otherwise, you could do something funky. The next thing we're going to require is two things on the metadata, so the collection metadata stuff. So first, we're going to do the accounts.ticket metadata collection. We're going to make sure that the collection is verified, because if it's not verified, that means you can't guarantee that the ticket is part of the specific collection. So we have to make sure that the collection is verified. There we go. If it's not verified, we want to output the error not verified. The next one, we want to make sure that it's actually part of that specific collection. So .ticket underscore metadata .collection as ref. So let's make sure all this is right. This is not right, so let's just get rid of some of this code. Boom. So as ref unwrap.key. So we have to make sure that the key equals the context accounts.collection mint.key. If not, it's the incorrect ticket, so it doesn't belong to this collection. All right. Now we have to, for some work on the front end side, we have to make sure that the ticket name .toOwned. Let's actually check. What is this name? All right, so this name is that ticket name. So we have to make that this ticket name, we have to make sure it matches the name that is expected. So that number 3 needs to be ticket number 3, right? So we have to do some work on concatenation. So we're going to just do ticket name .toOwned context.accounts.token lottery winner toString. So we have to add them together. Whoops, token lottery winner toString. There we go. And why is it failing? Let's see. Error unexpected semicolon. Oh, I have a semicolon set equals. There we go. And save it. There we go. I'm going to do a couple enters. All right, so let metadata name equals, this is going to be the context.accounts.ticket metadata. We're going to have to do name. We're going to have to remove some of the extra values. Otherwise, we're going to get some weird values in our name. You can go ahead and try this without this code that I'm writing now, and you'll see that it'll give a lot of like extra values that didn't belong. All right, there we go. So we have the ticket name, the metadata name, and now we need to require that the names match. So require, this is going to be the metadata name equals the ticket name. If not, it's the incorrect ticket. And we also have to make sure that the specific winning ticket account is actually there. So they didn't just create a token account and doesn't have any tokens in it. That would be bad, right? Because they didn't buy the ticket. They just created an account to hold the ticket without the ticket. So let's make sure that exists. This is ticket account dot amount is greater than 0. And if it is greater than 0, if it's not greater than 0, we need to say no ticket because they're trying to cheat. So next thing we have to do, we have to just basically transfer the lottery pot amount. So accounts.token lottery.to account info. We have to pull out those lamp ports from our account, borrow, let's see, minus equals the context.accounts.token lottery pot amount. There we go. And then we have to transfer it out to the winner. So pair to account info plus equals the lottery pot amount. And then finally, we need to set the lottery pot amount from token lottery so that they don't just keep draining our lottery amount or something. Say we start a new lottery with the same amount or something. We want to make sure that they're not just constantly draining. There we go. All right, we set it to 0. Let's do an anchor build, see what happens. All right, awesome. It built. Now we have to actually write the test for this claim. All right, let's just write this test real quick. So we're going to do const claim ix equals the await program dot methods dot claim winnings. This is going to be used with that specific account. So accounts, we're going to have to make sure that we use the specific token program. So token program equals, we're going to just use the normal token program, not the extension token program. There we go. They have instruction. Now we have to do the same thing we've been doing. So const claim block hash with context, and then const claim transaction equals new anchor dot web3 dot transaction. There we go. Create all of our fee pair stuff. Add the specific claim instruction. Let's see, it added an additional thing there. So we have our instruction now. Now we pull the signature. There we go. And finally, we log it. All right, let us restart our validator and run this test and see if it works correctly. So we restarted the validator. Now we just need to run the test. All right, so it failed. Let's figure out why it fails. Failed error BC4. Okay, so what is BC4? So we got a reveal. Transaction simulation failed. This is on the send and confirm of the claim. So let's go see what BC4 is. Hex to decimal. This is what you do all the time when you run into these weird values. 3012. So anchor error 3012. Let's see what it is. Account not initialized. So it's saying some account that we have is not initialized yet. Let's go figure out which account it was. So let's look at this real quick. Let's see. The winner chosen was, is that 3? Let's see. Oh, it didn't tell me. So let us go ahead and skip pre-flight. There we go. And run it again. So we'll just kill these. And then we have to skip pre-flight and make sure that it's all good. Okay, so let's go grab that signature. We grab that and go put it in the Explorer. The reason why we do this is we get a little bit more information. We can see here, oh, the ticket metadata, account not initialized. So this program are expected. So it says that our ticket metadata was not initialized, which is very interesting. We had the token, but the ticket metadata was not initialized. So let's go pull that and double check that I wrote all the code right. So we go over here, we go, there we go. It's just metadata. We misspelled metadata. That's an okay error. I'm okay with that one. So let's go ahead and run it again. And this time, let's see if it completes. All right, so it passed. Let's go look at that claim, make sure everything worked as expected. So there we go. There's our claim signature. We can check real quick. Oh, there we go, 0.65. So we gained some SOL over from the specific claim, the claimed winnings. It went 0.65. It should be the number. Let's see, how many of our tests did we buy tickets? How many tickets did we buy? 1, 2, 3, 4, 5, 6, 7. Is this 7? This is 7. So 7 times, was it 7 times 5,000? Is 5,000 the amount that we said? No, it was 10,000, right? Let's see, where is our specific initialized instruction? Oh, so there's our buy. There we go, it's 10,000. So 7 times 10,000 minus 5,000 for the land ports, for the fee. So because this is our fee. So we can see that the 7, there we go, was transferred from our token lottery account to our account, and we're good. We did the claim. So congratulations, we have created a token lottery. And just to generally recap what we did was we created a token lottery where you bought tickets that were tokens in a collection in order to enter the lottery. Those tokens created a fee that went to a lottery pot account. That lottery pot account was then used later to claim the winnings when we claim the winner. To figure out who the winner was, we used switchboard randomness function. So we used some on-chain randomness. It's not truly on-chain, it's off-chain, but we're using a commit reveal function so that it's easily verifiable. And we use that to create our randomness, choose our winner, and then create it in a trustless manner and give the winnings to that winner. So that is a lot of different things or concepts that we've learned throughout this token lottery project. We will be using this in the future in the bootcamp. So look forward to that. If you have any questions or run into any issues, just check the GitHub repository, join the discussions there. But thank you, and let's go to the next one.